Okay, good morning. Welcome to
FunMath155.
Math is so fun today that we're doing two movies called Fun Math. So we were studying section 8.6 of Art of Problem Solving's algebra book today, and that was about understanding a little bit more of the geometry of lines and slopes. One example problem that we spent most of the morning on wanted you to look at the line that went from connected 0, 0 to 1, 2, and 0, 0 to minus 2, 1. And it asked kind of what was special about these two lines and what turned out to be special about them.
They're actually the same line. They're perpendicular. They're kind of...
Wait, are they the same line or are they perpendicular?
They're perpendicular.
They're perpendicular. They're definitely not the same. One goes this way and one goes that way. Okay, and so we started talking about rotations. And so can you give an explanation as to why this, when you rotate 90 degrees this way, why does this point 1, 2 go to this point minus 2, 1? Can you try to explain that?
Well, we have two triangles here. This line right here is too high.
Okay.
And one long.
All right. And what happens to this line that's too high here when you rotate 90 degrees?
It becomes this line.
Okay. And it's also too long, but what does that end up meaning? It's too long in this direction.
Means it's negative 2.
It means the x-coordinate's minus 2.
And but it's still 1 high.
It's 1 high. So this triangle, that's a good explanation. This triangle that you've drawn here goes to this triangle here. What if you had drawn this triangle over here instead? This one. Can you tell me where that triangle gets rotated to?
To this one.
This shaded in. That's fine. Good job.
It becomes that triangle.
Very good. Good job. So and this was kind of tricky, right? Understanding where different points went when you rotated 90 degrees. But I'm going to show you there's a really neat connection with I. Do you remember what I equals?
I is the square root of minus 1.
I is the square root of minus 1. So there's another, there's a completely different or sort of different way of looking at this situation. Instead of labeling this point 1, 2, we're going to call this point 1 plus 2i. Okay?
Whoa.
1 plus 2i. So the x-coordinate is the real part and the y-coordinate is the imaginary part. And instead of talking about rotating by 90 degrees, we're going to talk about multiplying this by I. So 1 plus 2i times I. I'm just going to multiply this by I and see what happens. Now, we have to multiply 1 by I and 2i times I. What is 1 times I?
I.
I, right? So this is I. And what is 2i times I?
2i squared.
Plus 2 times I squared. And what is I squared?
It's minus 1.
Okay, so this is I minus 2. And the typical convention is to write the real number first. So this is minus 2 plus I. Okay, so where would the point minus 2 plus I be? Well, we said the x-coordinate is the real part and the y-coordinate is the imaginary part. Well, what's the real part here is minus 2, so we would be looking for a point that had an x-coordinate of minus 2. And the y part is the I part, so we'd be looking for a y of 1, 1i. So this would also be the point minus 2 plus I. And I, you can think of geometrically, believe it or not, as a rotation of 90 degrees counterclockwise.
Whoa.
Whoa. Can you believe that? So I, we've only talked about I in a couple situations. We've defined it as the square root of minus 1. We talked about this formula, e to the pi I plus 1 equals 0. I haven't explained this formula. I just said this connects a bunch of really famous numbers.
Yeah.
But here's an actual geometric interpretation of the number I as rotating by 90 degrees. Can you believe that?
Whoa.
And this interpretation of I is really important. Do you know why?
Why?
Because like 10 years from now you'll learn why it's important. All right. Good job. I just wanted to show you this because it's a neat connection between what we were studying today and a really cool math concept. All right. Good job.
Yeah.